So for our equations, when we have a vertex that's hk, it affects our equations like so. If we have the y squared version, this is how it affects it. If we have the x squared version, it affects the equation in an analogous way. Instead of y squared, we have y minus k. Instead of x, we have x minus h. And that's going to shift the vertex of our parabola up k and to the right, or up k to the right h. How do we feel about those equations? Pretty good? Okay. We just want to get right into using them. These problems can get kind of long. We're going to skip example 2, this first one, because it's the most involved one. We're going to come back to it. We're going to jump right to this second example at the bottom page in your next page of notes. Find the equation of the parabola with vertex at 1, -2 and focus at 3, -2. What's the first thing you should do with a parabola problem? Graph it. Step 1, graph what you know. What are you doing here? What do we know? We know that the vertex is at 1, -2. We know that the focus is at 3, -2. So you just want to graph those points, get them down. Focus at 3, -2. Okay. You have those points down. Tell me something about the equation of this parabola. What's it going to look like? The general look. Y squared. It's opening right. We have our focus to the right of our vertex, so we're opening right. This means we're going to be working with our y squared. Okay. Write me the equation of this parabola. What are we getting? Someone be willing to walk me through it. My general form is y minus k squared equals 4p x minus h. Fill in the blanks for me. Y minus k, what's k?
-2.
Yeah, it's from our vertex right here. K. K, h. So y minus a -2, y plus 2 squared equals 4p. What's p? 2. Why is it 2? It's the distance between the vertex and the focus. We know our focus is right here. The distance is 2. Our p-value is 2. X minus h, what's h? 1, yep. X coordinate of our vertex. Simplify. And again, when we say simplify here, you can leave it squared. Squared is fine. It's perfectly fine in that. Okay. I want to graph this thing. Remember when we were graphing yesterday, we picked special points to graph. Which points were those?
lattice.
We want the points that measure the focal width, also known as the lattice rectum. What are those points that we plug in? What are we plugging in?
You plug in the x equals 3.
You plug in the x equals 3. Right here, here's our focus. We know that our parabola is going to have kind of this general look to it. So we're plugging in the x coordinate to get the y coordinate. And we're going to have 2. Okay, so x is equal to 3, we're plugging into our equation. Y plus 2 squared is equal to 8 times 3 minus 1 is 2. Y plus 2 squared is 16. Y plus 2 is equal to what?
Square root of 16.
Right. What would that be?
Plus or minus.
Plus or minus 4. 2 answers here. Plus or minus 4, minus 2. What are my 2 answers? 2 and what? Negative 6, yep. 4 minus 2 is 2. Negative 4 minus 2 is negative 6. Okay. Tell me the coordinates of those 2 points that apply. So my coordinates, because I plugged in x, were 3, 2, 3, negative 6. Let's get those on our graph. So here's probably 2. So 3, 2. 3, negative 6, pretty far down here. General look of our parabola is just like that. Questions thus far? Slight modification of the things we were doing yesterday. Just moving our vertex. Okay, here's where things get a little bit more hairy. This problem is the one on the slide above. It wants us to rewrite in standard form and draw the graph of this equation. Now, if you might have guessed this is going to be a parabola, but it doesn't necessarily look like one. It's not in our standard form right now. We can't easily graph it. So our mission here, our goal, is to get it into something that we can graph. Something that's in our standard form. How should we go about doing that? Do you have any ideas, looking at the equation, how it is now, what the standard form will look like for it? It's going to be the y squared one. So y minus k squared is equal to 4p x minus h. Okay, why the y squared?
Because we have a y squared variable.
Yeah, we already have a y squared variable right here. So we can assume that when we get it into standard form, it's going to look like that. What steps do I need to take to get it there? Subtract 2x, all right. Alec wants to get the x's to the other side. All right, what now? Factor? Will factoring help? The 2y to the other side. In our equation, all our y's are over here, all our x's are over here. I don't think it'll help. We have something squared up here, y minus k squared. Think algebra 2 quadratics. What was one way we solved quadratics?
Or is it the perfect square?
Perfect square. We're going to complete the square. We have x squared plus 2y, we can add something to that to make it a perfect square. What do you want to add?
2.
2. Should we add 2? Is that a good idea? Will that work? Alex says no. Why? I heard 1. Okay. How did you arrive at adding 1? You're right. I just want. We need a general form here. 1 plus 1 is 2. Okay, so you're looking here and say, if I had y squared plus 2y plus 1, I could factor that perfectly into y plus 1 squared.
I thought it was just half of the
Half of what?
Yeah.
the variable in front of the single y.
This, in a general quadratic, this right here is our b value. We do half of b squared. That's the general method for completing the square. You take half of that middle number and square it. And in this case, that's just 1. I say that because you might end up having some problems on your homework where it's not easy to see what number you got. Half of b squared. But if I add 1 to one side, what do I need to do to the other side? Also add 1. Okay. We're good on the left. We got y plus or minus something squared, so that's good. How about on the right side? What do we need to do to get it into the form? We kind of need that x minus h. The 2 out, yeah. We need to factor something out to get that x kind of by itself. And I don't think we want to just factor 2. I think we want to factor negative 2. So we want to move negative 2 out front, and then what's going to be inside our parentheses? X minus 1 half. Okay. We have an equation written in standard form. Tell me, what's the vertex? What was that? Negative 1 half 1. Close. Half negative 1. Other way around. In our formula, it's x, or it's like y minus k. So if it's y minus k, then k's got to be negative 1. X is positive 1 half. That's our vertex. Okay? How about the focus? How would I find the focus? Let's say maybe the p value. Maybe that'd be easier.
Divide the negative 2 by 4.
Divide the negative 2 by 4. Why?
Because it would equal 4p.
So normally in our equation, this coefficient right here is 4p. So 4p is equal to negative 2. That's going to set our p value at negative 1 half. Okay, we have a vertex, we have a p value, we have a general equation. We can graph this thing. Let's go down here, let's do a little sketch. I've got a vertex at 1 half negative 1. Let's say that's 1 half right there. It's negative 1. There's my vertex. Can you place my focus? Where at? 0, negative 1. You're saying it's right here? Okay, why is Silver saying it's right there?
Because it's a negative and it opens to the left.
Okay, yeah. We have a negative p value. Remember, our p-values that are negative either open left or they open down. We have y squared equation, which tells us we're opening left. So, putting this all together, we know our p-value is the distance between our vertex and our focus. So we go left 1/2 to get to our focus. I'm going to write that up here. Focus, 0, -1. Okay. Graphed our focus, graphed our vertex. What points do we want to plug into our equation?
The ones on the focal.
The ones on the focus, you want to plug in what?
When x equals 0.
When x equals 0, yeah. We have a y squared equation. Here's our equation right here. Y plus 1 squared equals -2 x minus 1/2. We want to plug in x equals 0. Let's get y plus 1 squared equals 1. Is that right? Okay. Taking the square root, y plus 1 is plus or minus 1. Y equals plus or minus 1 minus 1. What are the coordinates of our 2 points?
0, 0, 0, -2.
X value is 0, 1 y value is 0, x value is 0, other y value is negative. Okay. Any questions right now? We have 20 minutes and 1 applied problem to do. We have 2 applied problems left. We're going to save 1 for Monday. Okay. Take a minute to read through this. Okay, you've read through it. The satellite dish is in the shape of a paraboloid of revolution. If the dish is 3 feet wide and 8 inches deep, where is the receiver module, also called the focus, located in relation to the vertex of the paraboloid? So they're telling you that this thing is a parabola. And this is true, receiver dishes are shaped like parabolas, which is why we have the name of a focus. How a receiver dish works is it accepts rays and then focuses them all onto a single point to amplify that signal. So that's why they call it a focus point on a parabola. Okay, the dish is 3 feet wide, 8 inches deep. First thing, when you're working with applied problems, you don't want different units. You don't want feet and inches. If I were you, I would change 3 feet, 36 inches. Yep. To make things easier. So the height, 36 inches, so 36. Depth is 8. Okay, here's where applied problems, you need to be really careful. You can make more or less work for yourself by where you decide to put the XY axis. You have the choice of where you want to put the origin. Where do you want to put the origin?
0, 0.
0,
the origin is always going to be 0, 0. Where do you want to put it on this graph? 4, 4. That also doesn't help me. You need to have the xy. You need to have the xy axis to know where 4, 4 is.
Like with the x-axis through the 8.
Put the x-axis through the 8.
Yeah.
Where's the y-axis going?
Straight down.
Straight down through where?
Through the
Just
8.
through
That
the
way.
farthest point. This way.
Yeah.
Yeah.
Why did we want to put it there?
Because
So works with our equations because we know exactly where.
Don't have to do the.
because then we know
The
like our
origins are
focal
0.
point.
The origin is 0, 0. Well put. 0, 0. Okay. What are we trying to find? In this problem. The focus.
Focus.
Okay. What can you tell me about the equation of this parabola?
There's a point at 8, 18.
There's a point at 8, 18. Okay. Here's a point on the parabola. 8, 18. Why 18?
Because it's half 36.
Yeah, we cut the dish in half with our x-axis. What about the equation?
It's y squared
It's y squared.
and positive.
Y squared equals 4px because we're opening right. We want to find the focus, which means finding which value. Okay, how do I find p? Plug in 8 and 18. We know 8, 18, 8 feet over, 18 feet up. We know that's on our parabola. Plug that into our equation.
Inches.
Anyone have a P gun? Calculator.
It's not a solid number.
10.125.
10.125. 10 and 1/8. So our focus is right out here at 0 and 10 and 1/8. Here's what the question asks. Where is the focus located in relation to the vertex of the parabola? So relative to the vertex, where's the focus?
To the right.
Inches.
It's 10 and 1/8 inches away from the vertex. The key thing with these applied problems, put your xy axis at an easy spot. Want your vertex to be at 0, 0. Makes it easier. Alright.
Focus point, reverse it.
Oh, right, yeah, that should be 10 and 1/8, 0. My bad. Any questions on this example? Alright. You are good to work on your assignment. 10.2 day 2. Yeah, Aaron. Sure. If you have any questions on 10.2 day 1, I can answer them. You can work through the board if you want. What's that?
Want these?
Yeah. Seriously, kid?
Do we have 39 and 41?
Yeah, we are. We're adding, remember, 39 and 41 got added to day 2.
Oh, I bet you those. Yeah, those are the tokens. Get that one down.
If you have this, I'll take it.
Do I need my name on it?
Sure.
Oh, this looks so bad.
Yep. Right there. It's all in here. pass it out for everyone.
Yes.